Hello, my name is Sean Campbell, and I'd like to talk to you about my project, FitnessPal. The main idea I had for this project was to create a fitness tool that would help people track their progress toward fitness goals. The initial design consisted of three views: one to integrate Apple Fitness data, one to save user created workout routines, and finally a running view that would allow users to draw their run path on a map. And here is the peak of the final design. I kept most of the same ideas, but shifted around where I wanted to use core data, table views, and a few other features. For the home view, I originally wanted to request and use the user's Apple Fitness data, but this level of access is only granted to paid Apple developer accounts, my application for which is still in process. So instead, I had to come up with a new idea. I came up with the idea to use the ring progress idea to represent progress towards a calorie goal using core data to keep logs. For the workout page, I decided to replace the use of core data and user created workouts and instead used an API call to a database of exercises that a user can filter based on a few optional parameters like exercise type, muscle group, and difficulty. For the map view, I decided not to use the table view of runs, as this functionality was also based on Apple Fitness data. So in the end, I decided to handle the tracking using core location and only allowed users one run at a time. More on that later. For the use case diagram, at the top, users can see their calorie progress, and if it is their first time logging in for the day, the system will create a new record for the current day in core data. Users can also log their calories, which will update the core data record. Any update to the current day in core data will be reflected in the calorie view's progress ring. In the middle of the diagram, there is a use case for searching exercises. When the user searches for exercises, the system will fetch the results from an API call and map them to a struct that can be identified. This allows the results to be displayed in a table view. Finally, at the bottom, the users can start recording their run in the map view. The system will begin tracking the user's location and plotting the path with the run path renderer. Now I'd like to quickly go through the UI and some of the capabilities of the app. On the landing page, the user will see the calorie tracking view. On each new day, the core data controller will replace the current record with a new one. Users can log their calorie entries throughout the day to see their progress. The workout view is represented through a table view, with detail views for each result. At the top of the view, users can add filters to the type, muscle group, and difficulty filters to specify the kinds of exercises they would like to see. Finally, on the run view, users are presented with a map view, with which they can start tracking their run, which is plotted using MapKit annotations. Another capability that I am happy to have with most of the work handled by Xcode is light and dark mode that reacts to the user's system settings. There are a few limitations to the app, on the other hand. One such limitation is that the calorie tracking data only uses the last record, or the current day. That means that all of the other dates that are stored are unused, and that data is unrepresented. So as future work, I would like to find a way to represent that data. Another limitation is with the map view, as I would have liked to measure and show the users more information about their run, like top and average speed, as well as the distance traveled. Moving on to the MVVM diagram. This diagram showing is a simplified version because this is the full version. To start, I want to point out that I chose to hold each of my views in a tab view from the main content view. This had two main effects to my overall implementation. One is that this allowed a navigation flow that I preferred to using segues, but also each view and their respective functionality is completely isolated from one another and the content view itself. For this latter reason, I could create and now address each view by themselves. Starting with the calorie view, we have the calorie tracker. At the top of the view, there is a component called calorie view, which acts as the view model. Calorie view creates the ring view in the bottom right and communicates with the core data controller at the bottom left. In the core data controller, there are two entities, calorie entry and calorie goal. Calorie entry stores the logs of calories and the dates, while goal represents the user's calorie goal. There's only one goal, and the core data controller provides a function to change it. For the calorie view, the main function of the core data controller is to allow the logging of entries by date and to show the last record. The last record is used by the view model as a state variable called percentage. If the user opens the app for the first time of the day, the core data controller will create a new entry and automatically replace the previous last record. The view model listens for changes in the core data controller's last record and assigns it to this percentage variable. The percentage variable is used as a binding variable in the ring view, which animates the progress ring. The view model also contains the UI that allows users to log calories for the current day. When the user logs calories, the view model calls the core data controller, which updates the last record and passes the update down to the progress ring. For the workout view at the top serves as the view model, which holds the UI for users to enter a search, which is used to fetch workouts from an API call and update the view with a table view of their results. The workout model defines the workout struct to be decodable to allow the API call to decode the JSON results, and identifiable to conform to the list or table view. I chose not to use an observable object here because it made more sense for me to handle the data in the view model, where I had to filter the JSON results already. Lastly, the list view allows the navigation to the detail view to see each exercise in more detail. Finally, we have the run map view, for which I reference sample code from the Apple developer MapKit documentation to create a run map using a storyboard with UIKit and MVC architecture. The map view controller is the MVC controller that has several responsibilities. First, it prompts the user to allow background tracking while using the app and starts tracking when prompted. It uses the run path model and run path renderer to draw on the map view. The run path model notifies the controller when the newest location is a sufficient distance from the previous location and when the newest location is out of the map bounds. The map view controller uses these notifications to update the run path data and update the map view. The user has access to basic map controls and a toolbar that has buttons to find the current location, change tracking settings, and start and stop recording, all of which are supported by the map view controller. To wrap this up, I'd like to let some demo footage play out while I talk about some lessons learned and final thoughts. I think this project served as a great learning experience. Having to come up with the entire UI and functionality from scratch really forced me to take in and apply the concepts explored earlier in the course. Moreover, it was definitely a learning experience trying to come up with the architecture design ideas in Phase 1 and trying to stick to this guideline while creating the final code base. As far as improvements for the class goes, I don't really have much to say. I thought the relatively simple labs combined with the more intermediate homework assignments provided a good learning curve that prepared me to implement and solidify those concepts in the final project. Thanks for watching.